Welcome to cseguru. The next topic we will discuss is traveling salesman problem. Under dynamic programming approach, already we have discussed Warshall's algorithm, Floyd's algorithm, knapsack problem, and knapsack problem using memory functions, and also single source shortest path problem using Bellman-Ford algorithm. Now we will discuss traveling salesman problem using dynamic programming approach. And before entering into dynamic programming approach, first we should understand what is traveling salesman problem and how it is implemented using brute force technique. So that we will discuss first, and then we will move to traveling salesman problem using dynamic programming approach. What is traveling salesman problem? Here, given n cities, the salesman has to start at the specified city. That is, one city he has to consider like a source city. Start from that city, and for example, here consider P as the source city. So start from the city and visit all n-1 cities. So here n-1 cities, there are other 3 cities. Apart from P, there are Q, R and S. Okay. So visit all the n-1 cities exactly only once and return back to the source city. That is the starting city. That is nothing but traveling salesman problem. Start from one specified city and visit all the cities exactly only once and return back to the source city. So this is nothing but the traveling salesman problem. And the objective of this traveling salesman problem is to find the route through the cities with the minimum cost. He has to travel from one city to another city with the minimum cost. The cost should be reduced. Okay. So that will maximize the profit here. So that is the main aim of traveling salesman problem. And this traveling salesman problem can be solved using brute force technique and dynamic programming technique. So first we will discuss how this TSP can be implemented using brute force technique. So in brute force technique, we have to get all the routes from one city to another city by taking various permutations. What is the possible routes? All the possible routes we have to consider and compute the cost of each route for each permutation and select the shortest one. That is the minimum cost. Okay. So here with the given graph, consider all the routes. Consider all the possible routes by taking various permutations, and for each permutations and each route, we have to compute the cost. Okay. Among the cost, which one is the shortest or minimum that we have to consider? That is nothing but brute force technique. And this brute force technique can be implemented using exhaustive sequential search. So here, exhaustive sequential search is nothing but compute cost of all possible tools, we have to compute the cost and select the tool with minimum cost. Okay, that is brute force technique. For example, solve the following TSP problem, which is represented as a graph. And this is the given graph with 4 vertices, and its corresponding root cost is also given. Where the cities are represented as P, Q, R, and S, and the distance between various cities are represented as numbers in each of the edge. So this is the given graph. So for this given graph, we have to implement a traveling salesman problem using brute force technique. So here, consider the source vertex as P. So that is starting vertex is nothing but P. So first we need to find the adjacency matrix for this given graph. So now we have to fill this adjacency matrix. So P to P, there is no root, so 0. P to Q, cost is 3. And P to R, it is 6. P to S, 8. Q to P, 3. Q to Q, 0. And Q to R, it is 9. Q to S, it is 4. Similarly, R to P, 6. R to Q, 9. R to R cycle, it is 0. R to S, it is 2. And S to P, 8. S to Q, 4. S to R, 2. And S to S, 0. So this is the given adjacency matrix. So what is brute force technique? We have to compute the cost for all the possible routes. So what are all the possible routes? Starting vertex is P. Okay. So one possible route is P to Q, Q to R to S. And S to P. Q to R to S, and then S to P. So what is the cost we will get here? P to Q, it is 3. And Q to R, it is 9. It is 12. And R to S, it is 2. 14. S to P, it is 8. So we will get 22 is the cost of this route. Next possible route is P to Q, Q to S, S to R, and R to P. So P to Q, Q to S, S to R and R to P. And what is the cost of this one? P to Q 3, Q to S 4, 7, S to R 9 and R to P it is 6. So we will get it as 15. Next step. So now through P as second vertex it is over. Now select the next vertex R as the second vertex. So P to R. Two possibilities will be there. P to R, R to Q, Q to S. R to Q, Q to S. And then S to P. Okay, here starting and the end vertex should be same. Because the salesman has to start from one vertex and return back to the same vertex. Okay, that is traveling salesman problem with minimum cost. So this distance if we are calculating in the sense P to R is 6, R to Q it is 9, 15, Q to S 4, 19, S to R 21 and R to P it is 27. So this cost is 27. Next possibility is P to R, R to S, S to Q and Q to P. And if we are calculating this cost in the sense P to R 6, R to S 8, S to Q 8 plus 4 12 and Q to P it is 15. So this is also 15. And the next possibility is through S. Now through Q over R over through possibility S. S as the second vertex. Okay. So P to S, S to Q and Q to R again R to P. So cost is P to S 8, S to Q 4 12, Q to R it is 9, 12 plus 9 21 and R to P 6. So totally we will get 27. Next P to S, S to R, R to Q and Q to P. And this cost if we are considering P to S 8, S to R 10, R to Q 19, Q to P 20. So here the cost is 22. So among this one if we are considering, we have to select the route with the minimum cost. So which one is minimum? So the cost 15 is minimum. So this route is minimum. Similarly, this route is also minimum. Both same minimum cost only. So the salesman can choose any one route among these. Okay. So this is the minimum cost. So this is nothing but traveling salesman problem using brute force approach. And what is the time complexity using this brute force approach? In this brute force approach, we have to consider all the possible routes. Okay, suppose if n is equal to 2 in the sense, that is number of vertices is 2 in the sense A and B. If you are considering this, only one route. Okay, so here only one route will exist. Okay, that is A to B, B to A. Okay, so this is the route. Suppose if n is equal to 3 in the sense of A, B and C if we are considering in the sense, there are three vertices in the sense, two routes will be available. A to B, B to C, C to A or otherwise A to C, C to B, B to A. So possibly two routes will be there. Suppose if n is equal to 4 in the sense of A, B, C, D. If you are considering in the sense, all possibilities will be there. Okay. So here if you are considering 6 routes will be available. How? That is A to B, B to C, C to D and D to A to B, B to D, D to C and C to A. This is one possibility. And through C, A to C, C to B, B to D, D to A and A to C, C to D, D to B, B to A. And through D, if you are considering A to D, D to B, B to C, and C to A to D, D to C, C to B, B to E. So if you are considering the possible routes are 6 routes will be available. So generally, if you are considering, this is n minus 1 factorial. Suppose if n is equal to 2, in the sense we will get 2 minus 1, 1 factorial. Okay, so here n minus 1 factorial in the sense, that is here n is equal to 3. 3 minus 1 factorial. So we will get 2 factorial. So total number of roots is here 1. Here total number of roots is 2. And here if we are considering 4 minus 1 factorial. So here we will get 4 minus 1 in the sense 3 factorial value we will get it as 6. So totally we will get 6 roots. Since brute force approach will consider all the possible permutations. And for each permutation, it has to compute the cost. That is the root cost. Okay. So generally, if you are considering in the sense, the time complexity of brute force approaches, this is O into N factorial. That is time complexity. F of n belongs to O into n factorial. Okay. So this is the time complexity of brute force approach. And what is the advantage and disadvantage of this brute force approach? This brute force approach always gives the optimal solution. That is the best solution. So here it gives the minimum cost so that it will maximize the profit. And it is a straightforward approach. Nothing to confuse. It is a straightforward approach. Find the permutation of all possible routes, and for each route, compute the cost. Select the one with the minimum. So it is a straightforward approach and a simple technique. So these are all the advantages of brute force approach. And the disadvantages, if you are considering in the sense, it is an inefficient method because it has to compute all the possible permutation of n minus 1 factorial. Suppose if the vertices is 50 vertices in the sense 50 minus 1. So totally 49 factorial, all the possible routes we have to compute the cost. Is it possible? It is very tedious. Okay. So it is a time consuming one to find the optimal route. So if the number of vertices is small in the sense, it is possible to compute all the permutation, and for all the permutation routes, we will compute the cost. But if n value is very large, in the sense, it is very time consuming and tedious task to compute the cost. Okay, so that is the main disadvantage in brute force approach. And this technique can be efficiently implemented using dynamic programming approach. That we will discuss in next video. Thank you for watching this video.